Hello, my name is Ruth Whittington, and I'm the Riparian and Wetland AIM Data Analyst and a Wetland Ecologist at Colorado Natural Heritage Program. The following presentation will cover hydric soil indicators as defined by the National Resource Conservation Service and highlight horizon and color patterns used to identify these indicators. You can follow along in the hydric soil indicators section of Appendix M of the Field Protocol for Lentic, Riparian, and Wetland Systems. Across the West, there are as many as 24 different hydric soil indicators. For this reason, I will not be aiming to cover these individually, but rather to teach you to recognize groups of indicators to select from based on what you see. It may take a long time to get a good handle on these indicators, so be patient with yourself and refer regularly to indicator descriptions found in the Field Indicator Guide. Hydric soils are defined by prolonged periods of inundation or saturation resulting in the depletion of oxygen. Through various biogeochemical processes caused by anaerobic conditions, this depletion of oxygen results in distinctive characteristics that persist in soil even after the soil has dried out. Hydric soil indicators, first defined by the National Resource Conservation Service, use these characteristics to identify and delineate hydric soils in the landscape. Full definitions for all indicators can be found in the Field Indicators of Hydric Soils in the United States, seen in the upper left-hand corner of this slide. Additionally, there are region-specific supplements, like the supplement for the Arid West shown on the right side. Hydric soil indicators are intended to be location-specific. For each Land Resource Region, or LRR, as shown in the map on the bottom of the slide, there is a limited list of indicators which can be expected to occur. A list of indicators used for each LRR can be found in the appendices of both manuals shown on this page. And the LRR a particular site falls into will be provided in the plot information within the Field Maps app. Additionally, different indicators can be expected based on soil texture. For this reason, all indicators fall into one of three categories. A indicators may be applied to all soils, independent of soil texture. S indicators should only apply to soils with sand or loamy sand textures. F indicators should apply to loamy or clay textured soils. So what does an indicator actually look like? Here we have an indicator as written in the Field Indicators Guide. I find the indicators can look a little intimidating at first, but they're really just a list of requirements against which you should compare your soil profile. Here we have an indicator A11, depleted below dark surface. First, it'll tell me which LRRs it's associated with. Then in purple, we have the bulk of the information we need, which is the depth, thickness, and color requirements for soil. Here we need a gray horizon, i.e. low chroma, that is either 15 centimeters thick or 5 centimeters thick if it is fragmental. In blue, we get a little more information about the horizon requirements for the horizon above, which needs to be dark, low chroma, and low value, and start within 15 centimeters. Finally, in orange, there's a bit more descriptive information that may provide more context. In this case, it defines the word depleted for us. So if we put this information together, we're looking for a soil profile, first with a dark horizon on top, underlain by a horizon that is gray in color. These descriptions can take some time to work through, so it can help to read through some of them to familiarize yourself to their structure before trying to apply them in the field. Most indicators include specific color requirements, often phrased as, this horizon must have a chroma less than 3 and a value greater than or equal to 4. Most often, these requirements are placed on the chromas and the values rather than the hue. In terms of the Munsell color book, this means that most indicators are describing the area of the color page that it falls on rather than which page you are using in the first place. I always recommend considering what the color requirements really mean when looking at a color page, so that I know I'm looking for gray colors, not just numbers for chromas and values. When it comes to wetland soils, indicators are usually defined by a specific pattern of 3 main color palettes. The first main requirement is roughly associated with high organic content, i.e. dark colors, meaning low chromas and low values. The second main requirement is for areas that have been depleted of iron and manganese, which will have a light gray color, meaning high values and low chromas. For some indicators, borderline colors for depletions may also have a percent requirement for redoxymorphic features seen within the horizon. Finally, the third main requirement are colors associated with redox features. For iron oxides, these show up as orange and red with high value and high chroma. But redox depletions can also have blue, green, or gray colors called gleying. These colors are found within their own Gleyed pages. At this point, I'm going to go through several categories of hydric indicators to start showing the patterns of the indicators you should be looking for in your soil pit. Keep in mind that for all of these indicators, you should refer back to the manual for the specific requirements of the indicators themselves. Complexity of indicators vary widely. For example, the easiest one there is to identify is probably A4. If you smell your soil pit and it smells like rotten eggs, you got the A4 indicator. Others may take more time to understand and apply. Try your best and expect that it might take some time to get these correct. The first group of indicators have thick organic horizons in the first 40 centimeters of the soil pit. These have to do with slowed decomposition caused by reduced oxygen availability. On the left, we're seeing indicator A1, indicating at least 40 centimeters of the organic soil is required. This is also the threshold to make the soil overall an organic soil called a histosol. On the right is A2, histic epipedon. This means that there's a thick organic horizon that is not quite thick enough to make it an organic soil. This indicator requires an organic horizon at least 20 centimeters thick. Next, we have indicators referring to smaller layers of muck, or mucky mineral soils. Be careful here, while the words muck and mucky have lay definitions, they are very specific in the soil world. Here, muck is referring to a sapric organic material, while the mucky texture modifier refers to a high percentage of organic matter without quite meeting the threshold for organic soil. Because mucky mineral indicators require that the percent organic material by weight fall within a precise range best measured in the lab, we will not ask you to call these indicators in the field. Depleted matrices result from manganese and iron compounds having leached out of soil horizons entirely, to leave only the mineral colors behind. What results is a bright gray horizon, often found beneath very dark horizons. Again, borderline colors often require a certain percent of redox features. That brings us to our next indicator. Redox features can appear either as part of the indicator requirements or as their own indicator. These are most often identified as bright orange and red flecks of color, but can also appear as blue-gray areas of reduced compounds. They can also occur as a splotchy patchwork called a mottle, with areas of bright orange oxide concentrations and dark blue-gray depletions. In all cases with redox features, it is important to record the percent cover, as this makes up an important part of most of their indicators. Finally, you may see gleyed horizons resulting from the reduction of iron and manganese compounds. These have blue-green or gray colors that may rapidly change within minutes as they're exposed to the air. With these soils, it is particularly important to take color immediately. True glaze should be colored using the Gleyed pages, but note that not all colors on the Gleyed pages technically qualify under the Gleyed definition. In practice, glaze and depletions can be difficult to distinguish in the field. Because indicators rely on color requirements and not chemical composition, let the colors you identify guide your indicator determinations. As you try to identify indicators in the field, know that some soil pits will qualify for multiple indicators, while others may not qualify for any. This may be for a number of reasons. First, remember that hydric soil indicators were developed for the purposes of wetland delineation. Because our target population expands beyond true wetlands into non-wetland riparian areas, some soils we sample may not be wetland soils. Second, some soils may be considered problematic, by which we mean they are wetland soils, but for some reason are particularly difficult to link to a specific indicator. For example, soils with bright red parent material often mask many of the distinctive color patterns we expect. Alternatively, some biogeochemical processes which occur in wetlands are not detectable based on visible changes. In these cases, make note of what you observe and don't stress if no indicator applies to a particular pit. This concludes the presentation discussing hydric soil indicators found within the Field Guide to Hydric Soil Indicators and Regional Supplements. Thank you for listening.